Hi, welcome. Today's exercise is not just going to be on this fidget spinner. The goal is to learn some basic Autodesk Inventor commands. And so we'll learn part creation, would assemble at the end of the day, which requires us to use some basic constraints. We'll also use the full round fillet command, the bearing generators that allows us to customize and choose a bearing that suits our work. Would also animate at the end of the day to get this motion you see. The dimensions will be provided as we go. Please consider subscribing to my channel if you're new. Like this video, it helps you reach a lot more people. Also, if you have questions, leave them in the comment section below and I will address them as soon as I can. Let's start. So to begin, we'll need a new worksheet, and so Control plus N. And since it's going to be one part of our fidget spin, we are going to select the part, create 2D and 3D object, and we will be working in millimeters. And so standard IPT is Inventor part file, and that is what we want. So we click on that and create. We'll begin with a 2D sketch, and so select the 2D icon, and we'll be working with the XY plane. Okay, so first of all, let's draw the inner circle of the fidget spin. So select the circle command and draw a circle through the origin of diameter 22 mm. Enter. Another circle up here, which is also of diameter 22. Enter. But then let's apply some constraints between these two circles. At this point, let's right click OK and see what we want to do. The circle is moving around, but we want to constrain it to just move vertically. So to do that, you select the vertical constraint option and click its center and the center or the origin. And now we have that constraint. Right click, OK. Let's apply some dimensions to fully define these two sketches. Dimension option, the distance between this point and that point is going to be 30 mm. Enter. Right click, OK. Now we have two more circles to make. We can just draw them here, but let's use the pattern command. It makes life easier. So select the circular pattern command and let's choose the geometry we want to pattern, which will be this one. The axis we want to pattern around, we can use the origin, so we click there. But how many instances we want? We want just 3 of them, and the profile looks good. The angle should be 360 degrees, which is fine, and so we OK. Now let's do something else. Choose the offset command. We want to draw the outer diameters of the circle. So to do that, the offset command, click on the circle and drag it out. The offset distance is going to be 6 mm, so 6 and then enter. We'll do same for the other circles. So you click, you drag, you specify the offset distance 6, enter. We'll do same for the last one, 6 and then enter. Okay, now let's connect these circles, the outer diameters. To do that, you choose the arc command and just click anywhere on the two circles you want to put the arc, and then you click to drag in. So we'll do same for this side. You click on the two circles, you drag in, click, and then you drag in. Right click, OK. Let's apply some constraints, which is a tangential constraint. So choose that command and apply a tangent constraint between the circles, the outer diameters, and the arc. So between this and that, you will see the tangent icon once the constraint has been applied. So this and that as well, this and that. And then finally this and that. Right click, OK. Now let's dimension the arc. The radius of the arc is 15. Enter. We'll do same for the others. 15. Enter. And then 15. Enter. 15. Enter. Right click. OK. 2D sketch is ready. Let's convert that into a 3D. So to do that, go ahead, finish the sketch. Let's zoom in and choose the extrude command. The profiles, let's specify the profiles, which will be this one, that one, this, and that. And we want the 2D sketch to lie in the middle of our extrusion. So we are going to choose the symmetric option. The distance of extrusion, we want that to be 7, and OK. As it stands now, our part is very deadly. The edges are too sharp. So let's apply some fillets to smoothen out the edges. So the fillet command, let's apply a fillet of 0.5. So we'll specify that and choose where we want to apply the fillet to. So the edges, which will be this, that one, here, there, this side, that side, this edge, and that edge, and then OK. We would apply some fillet also to the outer part of our body. And here we'll do something different. So drop down the fillet option and choose the full round fillet. And here we need to specify 3 things. That's the side A face, the center face, and the side B face. So the side A, we can just choose this face, and then the center face, we can choose this side, and then we can turn it for the side B to select the back side. And Autodesk Inventor knows what we want it to do, so it has given us a nice fillet. And then OK. Okay, so we will be inserting some bearings. We can draw our own bearings and insert them, but Autodesk has some in their library we can customize to suit this project. And so for now, let's just apply some material. So come up here under generic, you choose the first one, ABS plastic, and let's apply some color. So for here, I would choose, let me choose the orange red. Alright, so this part looks awesome. We'll go ahead and save it. So save your part. I'll save it, fidget spin or FS body. So FS body in my YouTube channel folder. Okay, and save. Okay, so we need to put the bearings in these holes. And to do that, since the bearing is a body on its own or a part on its own, we need to assemble. And to assemble, we need a new worksheet. So Ctrl+N again. And this time, we are going to choose the standard IAM assemble 2D and 3D component. So select that and create. Let's save this file, though we've not done anything yet. Let's save straight away. So save, and we'll save in the same folder. So we can make this FS assembly. Save. Okay, awesome. Now let's bring in our first part, which is the fidget spinner body we made. So up here, choose the place option and look for where you saved your fidget spin body. So FS body, I'm looking for it inside this folder. There it is, and then open. And now that is here, I just click and place. If I want another body, I'll just click, continue clicking until I get the number of I want. But this time I want just one. So let me right click and then OK. Okay, so now let's place in our bearings. So under the design tab, under the power transmission group up here, choose the bearing option. And we need to specify some details here. So Let's look at the first one, which is the cylindrical face. That is where we want the bearing to go. So for now, let's click on that and choose this face. That is where we want the bearing to go. But it's also asking us to specify the starting plane, which can be this face. Autodesk Inventor is not too sure of the depth of our bearing, and so over here we'll specify the depth, which is also the depth of our body, which is 7 mm, and here the inside diameter, that is where our shaft or whatever is going to go. We would also specify that as 8 mm. And then when you click on this option, based on the details we've specified, we have a number of options we can choose for the bearings, which some of them might not work for us. So let's continue specifying some details. And these options are angular contact ball bearings. And so let's come up here, drop down this option. Under standard, select BSI, and we want all ball bearing categories. And now Autodesk Inventor also gives us a number of them based on the options we've specified. And so for me, I'll choose the BS290, which is fine. And then okay, okay again. It takes a while, but our bearing appears. That's great. We want to place the bearings also inside the other 3 holes. We can use the copy and paste command. So we'll click here, right click, and then copy, and then we come here, right click again, and paste. Okay, but this is pasted not where we want exactly, so we'll apply some constraints. So come up here to the assembly tab, and under relationship group, choose the constraint option, and we want to constrain the midpoint here. Once you hover your mouse around, you see a line passing through the midpoint, which is the axis. So you click and then locate that same line inside the center of the bearing. You click. Then we have those 2 centers constrained. But then we want the bearing to also sit or flush with the face of this body. So let's apply some more constraints. So the constraint will be between the face of the bearing and the face of our fidget spin. We want it to flush, and so we'll apply. That's awesome. We can close this dialog box. Another thing we can also do is to pattern this bearing inside the other holes instead of copying and pasting. But first of all, let's place an axis inside this bearing to make our pattern easier. So under the 3D tab, choose the axis option and then hover your mouse around the middle where you want to put the axis, and then you click to place it. There it is. Now come back to the assembly tab, the pattern command. It's a circular pattern, so select that, and the axis here, which is the axis we just introduced, so we'll click on that, and then the instances we want, which is how many bearings we want to place in. We want 3, including the one we are patterning, and then this is going to be the bearing we are patterning, so we'll click on that and specify the angle. The angle is going to be 120, which means at every 120-degree angle we want a bearing to be placed, and everything looks good. The profile is okay, and so we okay. So as it stands now, our fidget spin is as rigid as can be. Let's apply some constraints to get it to spin around. And so to do that, we'll apply the first constraint between the center of the bearing, the axis of the bearing, and that of the assembly. So let's open up these origin tabs. Just click on the plus sign, and then we've opened that for the assembly. We click on that for the body. We open it up. Let's do same for the bearing, so we can select our planes. So we click on the plus sign and then the plus of the origin. Awesome. So we have access to all the planes. Like I said, the first constraint is going to be between the x-axis of the bearing. So we click on that constraint, and the axis of the assembly, the y-axis of the assembly. So we click on that, and then we see they snap against each other, and then apply. The second constraint can be between this face and the XY plane of the assembly. So we click on that, but they are away or apart from each other. So we'll click on the flash option and then apply. We can close the dialog box for now. And now it's able to spin around. So the body is spinning, and then also we get the bearing spinning. We don't want the fidget spin and the bearing, the body of the fidget spin and the bearing to spin independently. That's not how it works. So let's apply the final constraint to make sure they are spinning together. So the constraint option, and the constraint is going to be between the body and the bearing. So the XZ plane of the bearing and the XZ plane of the body. And then apply. We can close that dialog box. Now they both spin together. Okay, so that's pretty much it. But let's apply some final constraint. So we let it spin on its own. But before that, let's hide this axis. So click on that, right click, and turn off visibility. Now to make it spin on its own, we would apply the final constraint. So the constraint option, and this time, because we want it to spin, rotate in a 360-degree angle, we'll choose the angle constraint, and the constraint is going to be between the XZ plane of the body and the XZ plane of the assembly itself. Now for the angle, let's just choose directed angle and then apply. Close the dialog box. Down here to the work tree, and here with the angle we just introduced, right click on it and choose the drive option. Now we want it to drive from an angle of 0 degrees to, let's just choose 720. So it spins 360 twice, sort of. So 720, and then play. All right. Awesome. So that will be it for this tutorial. Kindly consider subscribing, help this channel grow. Do well to also like this video. It helps it reach a lot more people. If you have any questions, leave them in the comment section below and I will address them as soon as I can. I'll see you soon. Bye.